Hello again. My name is Jonas, and I work on debugging at Apple. And now I'm going to talk about the new status line in LLDB. All right, let's jump right in. Here I'm debugging the count utility, and this is what that would look like before the status line. I kind of had to cheat because I'm using a top of tree build, which has the status line, so I had to disable it in my LLDB init to show you the old look. So let's turn it back on. Here it is, the new status line. It's a dedicated area at the bottom of the screen. It is fully configurable using LLDB's format strings. This is an existing concept that you might have already used to customize the way your frames or threads are formatted. So let's look at the different components and how they are configured. So first of all, you'll notice that the status line has the fore and background colors inverted. This effect is called reverse video or negative, and that is our first format string. Because it reuses the existing fore and background colors of your color scheme, it's kind of guaranteed to look good in any color scheme, and so it makes a good default. But I would like it to match my solarized color scheme a little better, so I'll go ahead and change it. As you probably know, every color scheme has its own interpretation of the standard terminal code, so here black corresponds to this slightly brighter background color. Also, I had a lot of fun with supporting UTF-8 when I was doing this, so I'm going to throw in a bug emoji just for fun. All right, so let's move on. Next to it, we got the name of the target. So as I said, we're debugging the count utility. I don't want to have the whole path there because that would take up too much space. So we're going to restrict it just to the base name. Here it gets a little more interesting. So the next component is the source location of where we're currently stopped. I want to highlight two things. So first, we're using the vertical pipe as the separator. And then you'll notice that there's this extra set of braces on the outside. And these are used for scoping. And so with LLDB's format strings, what that means is that unless every format variable within that scope resolves, that thing is not printed. So if we didn't have a source location, we wouldn't show you the separator either. Next to it, we got the stop reason, which is a breakpoint, and then finally the progress reports. Where I'm stopped here, the debugger is idle, so there are none. And so here you see the scoping in action. There's no separator between the breakpoint and the non-existing progress message. So if you do an operation that does generate progress, that will show up at the end of the status line, plenty of space there. And just like with the alt inline status progress messages, if the number of operations is known in advance, well, we'll show you between square brackets, which is the progress.count variable in the beginning. So that is the default configuration of the status line. Here I'm going through a few of those format strings, but there's a bunch more. The LLDB website has a table that lists all of them with a little bit of explanation of how to use them to configure the status line and other parts of LLDB. So before I talk about the implementation, I want to talk a little bit about the motivation. So a big part of that was the progress events. Previously, if you have been using LLDB on the status line, you might have seen them in line. This was kind of fragile. The problem there is that even if you do have proper synchronization of stud out, you have to do bookkeeping to know which progress event was on screen so that you can clear it when it's over. And that gets really tricky when you have output coming from LLDB itself and from the process that you're debugging. And so this bookkeeping was kind of complicated, and it meant that sometimes we had to forego showing these progress events, which was really confusing to our users because then they didn't understand why they didn't see anything, and frustrating to the people trying to add more progress events to LLDB. And then the second motivator was customization. People always are looking for different ways to make LLDB their own, and a popular request has been to support these format strings in the prompt, but I think that the status line is a better way to do those things. Talking about the implementation, I could have used ncurses, which is an established library to make efficient terminal user interfaces. I didn't go that route because in order to do that, ncurses likes to take control of the whole screen and clear it, which is a big departure from how LLDB works today. So the alternative is to use ANSI escape codes directly, which is something LLDB already does for edit line, like multi-line editing. And so this whole feature kind of relies on one particular escape code, which allows you to reduce the scroll window of your terminal. So by reducing it by one line, we can basically pin the bottom line to the bottom of the terminal and give the status line exclusive access to it. And then everything else just operates normally in the scroll window above it. As I mentioned, it's enabled on top of 3, so it is available there today. So going forward, I think most of the work is going to be related to the format strings. I expect that as people start to use and customize the status line, there will be a request for more of these things to expose parts of LLDB. One other thing I want to support is default values. So right now, if you launch LLDB without a target, you just get an empty status line, which looks kind of odd. So I want to have the ability of saying, if this variable doesn't resolve, print something else like no target. And then during the RFC process, lots of people were asking about alignment and padding, which I think will allow for more interesting status line layouts. So please try it out. If you run into issues or you have cool ideas, please come talk to me or file an issue. Thank you.